Okay, so again, looks like there are 6 or 7 of us here. So does anybody, again, have a particular type of problem that they would like me to go over, or any specific problem from the review or from any homework, or you want me to just pick one? Okay. Okay then. All right. So let me pull up my screen here. Let's see. Okay. So let me pick a problem from the review sheet. Let me go with one of these ones where we're going to kind of just talk about all the different things that we could potentially be finding. I guess I'll do the one here with the graph, since finding the equation is good to talk about. Okay. Make sure that that stays where I want it. Okay. So just to check, can you guys see my screen and can you hear me okay? Yeah. Okay. All right. So for something like this, again, on the review sheet, it's just asking you to say everything you know about it. That's not really a great question for a review, but for a quiz rather, but it is a good review question because it just goes over a bunch of different things. Remember that for tomorrow, there isn't going to be any calculators. So obviously the things I have to ask you have to be relatively friendly. So again, I can kind of get us started. And then if questions get prompted along the way, you can go ahead and feel free to throw those out. So for something like this, if I was looking for something to start, I would say that this was a growth function. And I would say that it was growth because as x increases, y increases. You could also say that it's increasing at a decreasing rate. And I know that it's increasing at a decreasing rate because it's steeper over here on the left compared to the steepness on the right. So that's how I know that the rate is actually decreasing. From here, other things that I could say that the domain is all real numbers. I could say that the range is negative infinity to positive 3. I could say that the graph is concave down from negative infinity to infinity. I could say that the graph is increasing the whole time from negative infinity to infinity. Any questions, comments, or thoughts so far? Okay. Keep in mind here, you do have this equation. So if I give you an equation like that tomorrow, which I likely am to do, you want to make sure that you are utilizing that. So if you take a look at that equation there, a couple different things that I can say now. How about number 6? What's the value of C? Anybody can tell me? Okay, 3. And again, that is because it is the horizontal asymptote. Then if I was going to try to solve for the other values, if I know C to start, I would then find A. In order to find A, the best ordered pair that I could pick would be the one that's going to get this exponent to cancel out. And the best way for that to happen is if I use the point -2 comma something. And I think you can see pretty clearly here from the graph that that's the point -2 comma 2. So if I'm going to go ahead and try to find that A value, I'm going to go ahead and use my equation. And I'm going to say that 2 is equal to A times B to the -2 plus 2, and then plus 3, because that's the horizontal asymptote. I'm going to take this 3, and I'm going to subtract it over here from this 2. So 2 minus 3 gives me -1. Then this B becomes B to the 0, which just becomes 1. So I get an A value of -1. That should feel right because of the fact that it's below the horizontal asymptote. So once you have C and once you have A, it makes the most sense to then go and solve for B. So if we're going to try to find B, you need some other point on the graph that you haven't yet used. So you can't use -2, 2 again. And you want to make sure that you're using something else that you're absolutely certain is a point on the graph. So you could use -6, -2, I think is the best one. Kind of looks like -4 might be an integer, but maybe not. So I think -6, -2 is kind of your very best bet here. So if you go ahead and plug that in, you're going to say that -2 is equal to, you found that A was equal to -1. You're trying to find B. If you're plugging in the point, and again, we're using the point -6, -2, then you're going to go ahead and get B raised to the -6 plus 2, and then ultimately plus 3. So then from here, if you subtract the 3 from both sides, you're going to go ahead and get a -5 equals -b to the -4th. If both sides are negative, you can cancel them out to be a positive. We don't really want there to be that negative exponent, so you are able to rewrite this as 1 over b to the 4th. That's how you get rid of a negative exponent. If you have a fraction on one side, you can make it a fraction on both sides. And then just the rules of algebra say that you're allowed to flip both sides. So if you flip both sides, you're going to get 1/5 is equal to b to the 4th. If you wanted to get rid of that 4, you would take the 4th root. I would imagine that tomorrow your numbers will be a little bit friendlier because you're not going to have a calculator, but you could also just leave it as the 4th root of 1/5. That is, in fact, the b value. And then once you have all of that, you could put it all together to give you your ultimate final equation. So your ultimate final equation would be f of x equals negative times the 4th root of 1/5, all raised to the x plus 2 plus c. So you can feel supremely confident that that is, in fact, the equation that represents this graph. So again, if I ask you to solve for A, B, and C, which I think I probably will, you're going to start by finding C, then you're going to find A, then you're going to find B. So you're going to CAB it, I guess you could say. Any questions to there? Okay, so other things that I can say from this graph, and why don't I just take this and copy it again, just so I can have another reference here underneath. So now that I've done all that, even before I did all that, there were things that I could have said more generally about A, B, and C. So let me go ahead and talk about that. So if I'm going to go ahead and try to find a 10th thing, I know for sure that A is now -1, but I knew that A had to be less than 0 because the graph is below the horizontal asymptote. If the graph is below the horizontal asymptote, and if A is negative, that means that there is an x-axis reflection. I know that there is no y-axis reflection because of the fact that the equation that they gave me had a positive x plus 2 exponent, so there's no y-axis reflection. If I was going to try to, again, say something about B before I had actually solved it, this looks like a growth function, and it's a growth function with one reflection. In order for the function to look like growth after one reflection, I would know that the only way that that could happen would be if B is between 0 and 1. And just so you know, the 4th root of 1/5 is in fact between 0 and 1. Any questions about that? Okay. I talked about the concavity. I talked about the increasing. A little note about the end behavior. So as x goes to positive infinity, which is over here, I would say that f is going to 3. And if I was going to classify that as with or without bound, I would say that that was with bound because it's approaching a number. If I want to talk about the left-hand behavior, I'm talking about what's happening as x goes to negative infinity. As x goes to negative infinity, f is also going to negative infinity, and that would be classified as without bound because it's going down, down, down. I think the only other thing that I have on my list here is talking about the transformations. So again, that might be a good thing to do since some of us were having trouble with that in class. So if I go back to my original equation here, and again, let me just snip that so that I have it. If I go ahead and take a look at this original equation here, I can say that because of this x plus 2, if I take that x plus 2 and if I set it equal to 0, and if I get x equals negative 2, I can interpret that as meaning left 2. So if you're trying to take some ordered pair, x comma y, on the original, and in this case, the original would just be b to the x, then in order to change it to left 2, you would have to take every single one of the x values and subtract 2 from it, and then the y values would be the same. So again, this is how you describe the transformation in words. And then this is what I call the function rule, which would allow you to take any point on the original and then turn it into the new point using the transformations. So I'll show you some more examples with transformations. But before I do that, any questions on any part of this? Okay, and again, if you go to the actual answer key, it's got all these same things. And again, just listing everything that you know. It's a great review question, but maybe not such a great quiz question. So tomorrow it will be a little bit more precise, obviously. Talking a little bit more, again, about the transformations. When it comes to exponentials, we're usually much more concerned with the general behavior, the left side, the right side, the increasing, the decreasing, the concavity. But we do want to talk about transformations from time to time. So let me go ahead and just make up an equation here. Let me say that I had y equals negative 3 to the x plus 4 minus 6. If this was the equation that I was giving you, the next thing you'd probably want to do is identify the parent function. So the parent function would just be 3 to the x. So if the parent function is 3 to the x, that means that each of these changes, one in yellow, one in green, and one in pink, each of those has to do something. So you can start by writing them in words. The first thing that's happening is that the negative is a reflection over the x-axis. When you reflect over the x-axis, you have to change the y values. The second change is the minus 6. That means down 6. When you go down 6, you're also changing the y values. Then the third transformation is the x plus 4. The x plus 4, you would interpret that as left 4. And if you're going left 4, you are going to change the x values. So 2 changes to the y and 1 change to the x. So any questions so far on just identifying them? Okay. So then from here, if you're going to say that every point on the original is x comma y, I would be looking for you to write a new rule that tells me how to take those actual points, perform the transformations, and then get the new points. So I'm going to start by talking about the x changes. So the only thing that changes the x's is this left 4. If you wanted to take a value and move it 4 to the left, you would have to subtract 4 from it. So I'm going to write x minus 4. And yes, that's different than what's up in the exponent because it's different how it's written here and then how you actually perform it. This is the performance part, which means you have to actually subtract 4. For any point that exists on the graph, by subtracting 4, you're moving it to the left, and that's the goal. When it comes to the changes in y values, you have to do both this one and this one. You always, always, always do the multiplication first, followed by the up and the down. So you're going to have to first make the y values opposite, then go down 6. Then in order to actually move the points, you would have to find the value of some points on 3 to the x, and then you have to be able to perform this operation. That I think is probably the easy part. Identifying this is what some people seem to have trouble with. So if you were somebody who was having trouble, does that help? Or if not, can you ask me additional questions? Okay, let me do another one like this. So how about if I make up another equation? So let's call this one f of x equals, let's say 1/4 to the negative x minus 3 plus 6. So again, from here, the first thing you would do is you would identify the parent. The parent function would just be 1/4 to the x. So everything without the transformations. You have to tell me what this negative is doing. You have to tell me what this minus 3 is doing. And you have to tell me what this plus 6 is doing. So again, it doesn't matter how you list them. The first thing I'm going to say is that this is going to go up 6. I know that I'm going up 6 because of the plus 6. And if you're going up 6, you're changing the y values. Then the negative. The negative is what tells me that I'm reflecting over the y-axis. And if I'm reflecting over the y-axis, I'm changing the x's. Finally, in terms of the left or right, because of the fact that there's that double transformation, the negative and the addition or the subtraction, you have to take it and set it equal to 0. Add the x to the right, and you're going to get a minus 3. You have to interpret that minus 3 as left 3. If you're going left 3, then you have to change the x's. And again, if you want to take these two things and make it a little bit clearer, you can take the negative x minus 3, factor out the negative, and then once you separate that out, it's a little easier to see that this is the reflection and this is the left 3. So feel free to do that factoring if it's helpful. As far as then what you're going to do to some random point, x comma y, again, you're going to write me a new function rule that tells me how are the x's changing and how are the y's changing. So in this case, if I'm going to change the y's, that's only going up by 6. So you're taking whatever the original y is and you're adding 6 to it. Then in terms of what's happening to the x's, you first have to do this reflection. Then you have to do this left 3. So if you're first doing the reflection and then you're doing left 3, you can also distribute and just write it as negative x minus 3. So either of these two would be correct. They're equivalent. So you're going to use the one that makes you more comfortable. Questions? Okay. I mean, the truth of the matter is that covers, most of what is on this review sheet. So if I pull up the review sheet again, in order to answer the entire front page, you have to know whether it's growth or decay, and behavior, solving for A, B, and C. And we kind of went over that when we did question number 7. For question number 8, remember, this requires a calculator. But because I've already told you that you're not going to have one tomorrow, this would be good for you to practice on your own, but you do not have to worry about it tomorrow because you're going to have to use the regression. So if you feel like you have free time at some point, I would go back and do it, but not really an issue for tomorrow. Honestly, the only other thing that I can think of, unless anybody has a question, is the stuff about the like basis. So I can go ahead and give you one like that. Remember, when it comes to like basis, you can either be asked to just simplify or you can be asked to solve. So first I'll show you a simplify one. So let's say you have the square root of 8 to the 4x plus 2. And then let's say you were multiplying that by 16 to the negative x. The only way that you would be able to simplify this is if you're able to find some common base. So here you have an 8. Here you have a 16. The best case scenario is that one of those is the like base. If not, you have to go smaller. So 8 doesn't work. If you try to go smaller again, 4 doesn't work, which means you have to go smaller again to 2. So you have to realize that 8 is equivalent to 2 to the third, and 16 is equivalent to 2 to the fourth. And again, as far as tomorrow goes, I'm going to keep the numbers relatively friendly. So as long as you know a couple powers of 2, 3, and 4, you should be fine. So this 8 that's now 2 to the third, you also have to be sure to raise this to the 4x plus 2, which is also raised to the 1/2, because this square root is technically index of 2. Then times 2 to the fourth, now to the negative x. So in each of these instances, a power to a power, you're going to multiply these. So this is now going to give you 2 to the 12x plus 2. Oh, sorry, nope. So 2 to the 12x plus 6, still to the 1/2 power. This is going to give you 2 to the negative 4x. If you multiply again, you're going to get 2 to the 6x plus 3 times 2 to the negative 4x. In your final answer, combine the x's plus 3, and that is a single base raised to a single exponent, and that is what you would be looking to do if you just simplified. So any questions on that? Okay, same idea, although it just looks a little different, is if they said solve. So if they said solve, you're actually looking for x. So let's say you had something like 1/27 to the 4x, and let's say that that was equal to 9 to the 5x minus 1. You would be looking at the 9 and looking at the 27, realizing that those are not like bases. You would try 9, which doesn't work, so you'd have to try 3. If you think about 9, that's equivalent to 3 squared. If you think about 27, that's equivalent to 3 cubed. This is really 1 over 3 cubed, which means that you want to bring it to the top by making it 3 to the negative 3. So if you rewrite 1 over 27 as 3 to the negative 3, this is still to the 4x. If you rewrite this as 3 squared, this is still to the 5x minus 1. Power to a power, you're going to multiply. So this becomes 3 to the negative 12x. This becomes 3 to the 10x minus 2. Only once you have 3 to the something equals 3 to the something can you get rid of those somethings and set the exponents equal. Put all your x's on one side, so negative 22x equals negative 2. Go ahead and divide by negative 22. You're going to get an answer of 1/11th. And again, because this is a no calculator quiz, you can just leave your answer as such. Questions? So using these like bases, again, this is an important rule here, that if you have a power to a power, you multiply. This was another important rule here, whereas if you have base 2 and base 2, you're going to be sure to add those exponents. The only other one you have to worry about is, let's say you had 2 to the 5x plus 6 over 2 to the x plus 1. If you have it as a division, you're going to subtract. And when you subtract, you're going to subtract the top minus the bottom. So if you're doing the top minus the bottom, you'd be doing 5x minus x, which would give you 4x. Then you'd be doing 6 minus 1, which would give you 5. So I cannot think of anything else that we need to review, but I would be happy to go over anything if anyone else can think of anything. So does anybody out there have a question, concern, request, anything that I can do for you? I do think that this review sheet is pretty comprehensive. So I would say that if you can do this review sheet, and if you were okay with the like-based stuff, I think you're probably in pretty good shape for tomorrow. So let me just go back to the meeting here. Looks like we've got a few more people who joined us. But again, does anybody have anything either general or specific that they would like me to answer before we conclude? Going once, twice. Again, just be sure to read on Teams. It's 40 minutes, no calculator, 38 points. It is 10 total questions, and it is 5 of our multiple choice, and then 5 of them are open-ended, but some of them are multiple parts. Okay, hold on. There was a request for number 1 on the multiple choice of homework 32. Okay, so let's see. Homework 32. The first multiple choice. Okay. So which of the equations represents an exponential function that decreases with bound? And again, I think the easiest way to answer this question is to make a little sketch. So in order to do that, it's fine. Whoever says they have to leave, no worries. In order to do that, if you know that generally speaking, growth functions look like this, and if you know that generally speaking, decay functions look like this, that's a really good start. So for number 1, you have a growth function that's reflected over the x-axis, which is why it looks like this, and the horizontal asymptote is here. In number 2, you have a decay function that is moved down 3, so the horizontal asymptote is here. In number 3, you have a growth function that is reflected over the y-axis, which is why it now looks like decay, and the horizontal asymptote is here. If they're asking you whether they increase or decrease with or without bound, so decrease means that as the x's get bigger, the y's have to be getting smaller, which they're all doing. But if you're saying without bound, it has to be the one that is not approaching the horizontal asymptote. If it is approaching the horizontal asymptote, that means there is a bound. So the only one that's true is A. And again, based on all the talks we've had about B and reflections, that is what you would need in order to answer this question. Okay, anything else? Okay, well then if that's it, I think we're going to conclude. So I'll stay till I'm the last one, but if anyone thinks of anything else and they're too shy, let me know. Otherwise, thanks for coming. Good luck, and I'll see you tomorrow. All right, thanks guys. Have a good night.
Thank you.
Okay, bye guys.